he defined the air conditioning as the control of humidity of air by either increasing or decreasing its moisture content. So that means humidification or dehumidification. Also, he added another one called as humidity. Added to the control of humidity is the control of temperature by either heating or cooling the air, the purification of the air by washing or filtering at the air, and the control of the air motion and ventilation. This is what the beautiful definition given by the this thing in that. I just want to, because your figure always talks more than 1,000 words. I don't know how many of read this book called as Basics of Refrigeration Air Conditioning by Ananda Narayanan. I hope you must have read that one. Very simple book. Maybe majority of you must have read it. Or normally in Indian, we have refrigeration air conditioning by Professor Dr. C.P. Arora. That book normally we take it for the design purpose or to understand the concept. But for when this comes, this C.P. Ananda Narayanan, he was an ex-Voltas and then later stage he became a battery boy man. And he has written beautifully this book, mainly for the people who are on the servicing side, maintenance side, because he was a service manager. I still remember his first page. I still remember. Maybe you can also refer it. He was talking about why we need a compressor in a vapor compression system. Beautifully, he was explaining. And I have a, let us say, R22 gas. I put in my cylinder. The cylinder R22 boiling point is, let us say, minus 30, 36 or 39 or whatever it is. So if I keep in a cylinder and if I open slightly, then definitely the gas will expand. And when it expands, it evaporates and it needs the cooling. The cooling is taken from the surroundings. So thereby the room, wherever immediate to the cylinders, it gets cooled. And then, but at the same time, we are losing my refrigerant, and the refrigerant is being wasted, and it pollutes our environment also. So as an engineer, I was thinking that how I can retrieve back the refrigerant, because it become, after the evaporation, it become vapor. So, but it become a low pressure vapor. So how I have to do? For that purpose only, he was telling the compressor is required. A pumping machine is required. You call whatever it is. It may be a compressor or whatever it is in that. So same way, I also want to explain you, because variable air volume system basically related with the air, how the air distribution generally we thought actually. You have in all the psychometric processes taking place in air handling units. In the air handling units, simple parts, it's a cooling coil, there is a blower. Cooling through in the cooling coil, chilled water or water is going, or if it is a hot water coil, hot water is going in that. See, this is the figure. So the blower sucks the air, and then it through some pipe or supply duct, and it is going distributing, and it is offsetting the heat. So this is a simple thing. And then if I put this through how the supplier duct, how the air has to be distributed through the diffuser, that is called as terminal, supplier terminal. It can be a grills, it can be a diffuser, it can be a register, whatever it is in that. So similarly, when the cool air is supplied with certain temperature, as we know that the cool air normally supplied, say, 12 degrees centigrade or 14 degrees centigrade, and then it absorbs the heat from the room, then it becomes a warm air, and that warm air is taken through the return air grill. So then we have a different duct. This is called as a return air duct, correct? So this is how the return air duct is going. And then we have sometimes, as I told you, some of the same blower will also act as a return air, this thing, depending upon what type of blower you selected. Some places we have to use the return air fan in that. Then we have to also, for the ventilation purpose, you have studied so much ventilation, what type of air requirement per person, application to application, what type of cleanliness level you have to maintain, what type of clean room, what type of class you are designing. Accordingly, your application to application, your ventilation also differs. So for that, you need to add a lot of outdoor fresh air, because to keep this air in a good condition in that. So that for that, we have a fresh outdoor air. For that, again, we have a damper. Dampers are basically a control which regulates the flow of this air, all these things. Everywhere we are putting the damper in the system. Probably one by one, you can see the figures in that. So then some places we may need to use return air. Certain percentage we may have to throw away to the atmosphere or to the outdoor. So for that, we have exhaust duct. Some of the things, something we have to bypass it. And then again, we have to exhaust it here. Everywhere we have to use the filtration also. So this is what a typical overall final picture in that. How this typical all air system looks like that. So I just wanted to explain you the step by step. Why I started this step by step? Because I was thinking when I was reading the first page of that one, I thought that I should also figure wise I will do that. That is the thing I have done in that. So you can see this, how this chilled water chiller is there. From the chilled water pump, the chilled water is going through the coil, and then you have whatever the formulas, whatever the calculation you have done, accordingly the fresh air is coming, then it is passing through the cooling coil, it gets cooled and dehumidification. After that, there are some process. You will be adding in the AHU, and then the cooled and dehumidified air, it is going based on your calculation through the supplier duct, and the cool air is supplied through the supplier terminals, and from the supplier terminals, and then the cool air absorbs the heat from the air to be air conditioned, the enclosed spacer, and then it becomes a hot air, then return air, and the return air is taken through return air with the fan. Partially, some cases it will be 100% exhausted, like places like operation theaters and OTs. And some places, some percentage we return back. As I told you, some cases, depending upon the process, even the return air also has to undergo many process. Some places I told you, it may have to go through again air washer, because if you have so much dust particles, which we have done during our ordnance factory design, this was in 1918 era, 19 that. And then if it is a, even this chiller, we have a water cooled or air cooled. And if it is a cooling, if it is a water cooled means you have a cooling tower. Is another circuit in that. Overall circuit I put in that, because the whole picture I am trying to put on that. And then if it is a, you need a humidification control, you need a boiler. So I have added a boiler here. You can see that there is a boiler here, and then I have to add also on the heating and humidification coil in the heating coil also in that. So this is the overall typical all air system in that. So why I have put all these diagrams is the entire course so far what we have done. We focus particularly for the chiller is equipment side, pumps are equipment. The pumps also may be a primary pump, secondary pump, and then similarly boilers also different. Similarly, cooling tower is something different. This all comes under the refrigeration equipment. All these pumps related with the piping. So, but most of the time we focus on the air side actually. Mostly we are on the psychometric side, air handling units and the duct distribution and all the things in that.
Hello, sir.
So, yes, sir.
Sir, I have a question. May I?
Yes, please.
Sir, I am Pinaki from Durgapur.
Yes.
Sir, I can see here the return air is some amount of return air is mixing in the HU mixing box along with the fresh air, and some amount is exhausting through to the ambient. Okay.
Correct.
So how means what is the set point that how much air will be come into the mixing box and how much will be exhaust? So how we are deciding this, sir?
This is what our standards are there. This is what I have been talking now. For example, when you are designing hospital, when in the hospital, when you are designing operation theaters, the ASTRA 170 says that no return air. Everything should be completely exhausted. Correct?
Okay.
You don't take any return air. But if you want to take the 100, in the case of operation theater, we have to make the air changes also. How much? 25 to 30 air changes per hour, because it comes under the class either 100 or class 1000 in the clean room category. So in that category, we do, and moreover, the distribution also it should be a laminar flow. So, so that all in the previous classes we have discussed. And similarly, but if you are designing for the corridor or if you are designing for the administrative office, so you may take the normal comfort air conditioning. So the ventilation is very clearly defined per person. You must have done your heat load calculation. In the heat load calculation, what area wise, if it is administrative office, so that particular AHU, 80% or 90%, depending upon that, we are taking the return air. Balance 10%, it will go outside. And then that 20% will take from the fresh air. So that's what the air balancing we have to do. I have to supply 100 liters per second, total supply air. In that, I know 80-20 means 80% of 80 liters per second I'm taking return air and 20% taking a fresh air. And 20% it will go outside. But again, as when you come to the ducting side, we are again doing zone-wise. Single zone-wise also because we have a common planum. From the common planum, we have different kind of branch ducts. And branch ducts also we have different kind of collars. and then various zones also. Various zones have to be maintained, different temperatures, different controls are required, but we may be using only one air handling unit. So this is what, as a design engineer, during the pre-stage itself, depending upon the process. Now you cannot now put one air handling unit, which is common for operation theater, and which is same thing common for the administrative area or corridor area, isn't it? Okay. So that this is what the specification as per the ventilation, how much percentage. Now, for example, if you say split air conditioners, you don't exhaust anything. It comes the same air is returned again, because there is no ducting or nothing in that. That is the reason sometimes, majority of the time, people will go for a ductable or ceiling mounted type of this thing, where at least you have an opportunity to mix some planum is there, you mix some fixed air for the ventilation purpose. Otherwise, the person is sitting there, the same air is recirculated continuously, and if a person is working for about 8 hours, so the oxygen content will also get minimized in that. So these all various ventilation standards are there, depending upon the application to application, process to process. Yes.
Excuse me, sir.
Yes.
Sir, Shashi this side
yes,
from
yes,
Jaipur.
Please.
Yeah.
Yes.
So actually, sir, in the diagram you have shown the return air fan.
Yes.
Which is placed over it, right?
Yes.
And how a return air fan can become an exhaust air in the same supply, in the same return air duct? As you can move further now, that return air fan, the notation that you have given the exhaust air damper, and
Yes.
the duct is, you are seeing the duct, na sir?
Yes.
The return air duct
yes.
is coming, then it's connected
Yes.
to the return air fan.
Yes.
After it got connected to the return air fan,
Yes.
then it become an exhaust air damper.
Yes.
Then it goes out to the building and it
Yes.
becomes an exhaust air.
Yes.
So will you explain on this, sir, how a return air can become an exhaust air?
Yeah, this is only a schematic for the graphical representation. The concept is this return air, we call it, in fact, I should not call it as a fan. It is a blower actually. It can be, sometimes it can be even fan, axial flow fan also will be there. The concept is, some air handling units, you don't get even return air fan. Most of the air handling units, if you see in India, they don't go for a separate blower. The same supply air fan will suck it. It will supply, and same return air will come above, either through some places you may not have a separate ducting also. Simple comfort air conditioning, the return air is taken above the false ceiling.
Ramaswamy sir, can I bother for some time? I think
Yeah,
I've got his question, what he's trying to ask. I think
Yes.
he's been, I think there's some misinterpretation that between return air fan and the exhaust air, the
Yes.
terminology, what he has in mind, or what
Okay.
due to this all schematic. So I would just wish to throw some light over here. You
Please.
see, again, what Dr. Ramaswamy is saying, that it depends on application to application. For example, suppose there's a smoke inside the room. What you can do is simply this return air damper gets shut, and this return air fan acts as the exhaust. So all exhaust, all smoke in the room can go outside, and fresh air can be introduced and go outside. Now let's take case of the other case, like for example, marine and offshore applications. In this particular applications, what happens is that suppose a fire breaks out, then suppose this particular room is telecom room, then the air gets recirculated in the room. So exhaust air damper here gets closed, fresh air damper here gets closed, and only return air damper gets open, and air gets recirculated within the room just to have the cooling inside. So again, it depends on application to application.
This all only a graphical representation, I was telling.
Don't look at the exhaust damper. This all confusion because of the schematic, which is return
Because
air damper
if
and
you see
exhaust.
this figure, step by step I started. This is what I given my explanation. And if you see in Anandanaran book, like if you go to the whole first figure, you see, one by one I am adding. I just want a graphical representation so far what we have learned. So that is the idea. I want to just to summarize, because every class I always start how I started now. From the air conditioning definition, how is the symbol look like this? Like this is like a symbol, I keep my cylinder here, and then I open my valve and it will cool. And then what happened? Now, if you keep on this supply, okay, you have a cooling coil, then supply air fan, in the supply air duct is coming. So only supply air duct, I need some outlet for the airlet to go out. So I have shown the supply air terminal. So this is called as diffuser. It is called as a grill, or it is called as a register, whatever you call it, it's a different name. So one by one, I'm trying to explain, make you to understand how the schematically, so far what we learned. in the air, in particularly in the air conditioning air side actually. Chiller side, last I told you also. Then we have to also take return air. That is what step by step I was showing in that. How the return air we have to take, how much percentage, that is a different. It's only a graphical representation. Maybe the position also, maybe I put in a different way there, just to make you to understand. See, similarly, when this earlier diagram, I told the chiller. So the chiller I have not mentioned. Is it a water cooled or air cooled? So next figure, I put as a, since if it is a water cooled, you have another cooling tower, you have a condenser pump, because only water cooled system you have a cooling tower. In the air cooled we don't have. So just for your graphical representation, then we also have a steam humidification or humidifier, we need a boiler. So this is how the graphical representation on that. How much we have to do separate air conditioning, it is all depending upon your creativity during the pre-design. In the design stage itself, you have to go, you have to understand various selection of the HU roof and availability of the space. You have to interact with your architect. You have to interact with the end user also, starting with the data, because your data collection itself is basically an art rather than a science. When you do your heat load calculation, though you send a regular farmer to collect the data, majority of the time you don't get the 100% data. Many of the things you have to assume. And then when the assumption, you have to use the correction factor in that. Okay. So anyhow, as I told you, as such, HVAC systems are definitely a complex custom. That is the reason I have given this type of figure, whose performance depends on a various type of players. You are a design engineer and including manufacturer, because nothing is in your hand. You are doing your heat load calculation. After that, you are going to select it based on the manufacturer's catalogs. So even the performance of the chillers. So we have a performer, you have a leading manufacturer's carrier, train, and every manufacturer's claim this one. So on what basis? Again, costing is also one of the things. Various factors. Similarly, you are the design professional. Then above, even if you design 100% beautiful design, if it is not being installed properly as per design, and then again probably there is an opportunity the system will not work properly. And then even if you contractor installing as a project manager, there is a different aspect. There is a different segment. The project manager takes everything, and then he normally execute. As I told you, most of the time, air conditioning is a service. And then majority, the major contractors are civil contractors. So the project managers are civil engineering oriented. They may have a little understanding about air conditioning system. And then they always leave everything to the contractor. And then the system is installed. And then later stage, we have to also have a, depending upon, for example, if I want to have only 2 5-ton package unit. So probably I don't need sophisticated all these things. But at the same time, if I want to do a 1,500 bed hospital, in that design, definitely I need proper agents, proper contract consultant, proper testing notes, testing documentation, pre-testing, testing, and balancing, all these type of things in that. So as I told you, as a designer, we are in the process of coordinating the activities of the various entities in producing a product. So now if you consider air conditioning system as a one product, as a one big domain, it consists of various subdomains, basically from the equipment side, refrigeration side, air handling side, ducting side, piping side, then project execution side. So that all we are working for the owner of the building within the design constraint of the time and budget. So in between, even I told, once you make all your design documents, design drawing, your specification, everything, then you are also giving everything to the purchase department or the tendering department or the procurement department, whatever the name you call it. And they have their own commercial interest on that because they don't understand all these things in that. Some of the people, they will go for a costing in that. And so this all, definitely it's a complex process. This is what I, again, the main core point which I want to highlight to you is a 100% perfect system. No system is 100% perfect system. Every system will have some rooms for the improvement in that. So, but when you document, when you understand, when you update your skill, when you use your creativity, and this type of mistakes can be minimized. It cannot be completely eliminated in that. So again, so having said that one, what for actually, now we were talking about how generally what should be the supplier temperature, ideal supplier temperature, and how again graphically, how much, the return air is approximately, we supply to 12 degree to or 13 degree. Even if you go to the split air conditioners, you measure your grill temperature, how much it will be, 12 degree, 14 degree like that. And then if you see the return air, the filter, it depends upon, depending upon how much the size of the room. If you have a very big room hall, it's put 1.5 ton. If you have room sizes, let us say 15 feet by 10 feet, the return air will, though you thermostat you put it, but if you have a very big room, you may adjust the thermostat 22 degrees centigrade, but the thermostat will not cut in that. Continuously it will run. If you measure the return air temperature, it may show 26 degrees centigrade, isn't it? Depending upon various factors on that. So this is again same what I have told. This is what I was telling in that. Why we have to go for this variable flow supply fan, variable flow exhaust and recirculation fan. So same thing I put in a different format, various rooms. Here I have shown the rooms actually, various terminals. Why we need to go for this type of VAV system? For that purpose only. Various different kinds of zone will be there, different kinds of air handling unit. We have some, like for example, some of the hospitals, we may have 100 air handling units, and then maybe 200, 300 fan coil units. And the chilled water, again, fan coil, and also we have 2 pipe or 4 pipe. So these all just to recollect your knowledge on that. That's what I have said in that. So generally, we always have the questions on what should be the best choice of the supplier temperature. Always, because comfort condition I have defined. The comfort condition, ASHRAE has conducted a lot of research on that, and they have done in a called comfort zone in Psychometric Chart. And they also define within this temperature, basically from 20 to 25. So that is the reason generally inside condition we take 23 plus or minus 2 degree or 3 degree. So the maximum limit can go, similarly minimum limit can up to that run. So to achieve that one, what should be our supplier temperature? So particularly for VAV system, because why you are asking, I will tell you about the constant volume system also. Constant volume system, we have a different one. I will explain that time. So as I told you, supplier temperature is ultimately more important than the choice of the design air temperature. A system designed for 55 degrees centigrade can still operate at 60 degrees Fahrenheit. Depends upon various factors in that. So like ASHRAE standard, again, normally how they define, again, this another ASHRAE standard 5515. These are primary factors that affect thermal comfort. Metabolic rate, we discussed on that day about the various metabolic rate in previous classes, clothing, insulation, what type of cloth you are wearing, air temperature, how much temperature is going, radiant temperature, depend upon how much the convection actually. Sometimes, many times, are you going for the forced convection or natural convection for the air circulation? That's what we call as air velocity, then air speed, then humidity, and all these commercial systems. The space temperature is the only one of the 6 factors that is directly controlled, isn't it? Through the chiller, typically with a wall-mounted thermostat. But the humidity is indirectly limited on the high side as a part of the cooling process, basically cooling and dehumidification, and can be limited on the low side of the humidifiers. If you want, you have to add more humidifiers in that. So temperature and humidity are relatively constant throughout the most condition space. We know the zone also. The radiant temperature may vary significantly from surface to surface, depending upon how this surface wall and everything is exposed and what type of equipment nearby. So for that, that's what we have. It's not basically a normal thing. We are not able to control by the HVAC system in that. So ideally, when we do the duct sizing, we normally go for the static gradient method, or we have a constant velocity method. We have all software, all these things in that. And generally we use equal friction method, whatever it is. But static gradient method, academically, it's very good. When you do your course, every time professor will ask you all these type of 3 methods, you may have to design and you have to give the answer in that. And but every method has got its own advantages and disadvantages. And but particularly the static gradient method, it has got its own pros as well as cons. This I have just given in that. You know that all the things in that. But you should not, all the things we are doing with certain assumption, because all complete and perfect mixing occurs between all of the room and air in the supply air. The return air is leaving the room at the temperature of the room. It may not be true. Even if somebody wants to measure the temperature, actually clearly says, not in one measure. You have to measure in 4 corners, and then you have to take one in the center, and then you take the average of these 4 readings. It is not necessary. If I want a tribal, any technician, I always used to tell them, in a, let us say, 15 feet by 20 feet on room, I tell you measure the temperature. So the ideal ASHRAE standard says that You have to measure it 4 corners and in the center, and then you measure it and then take that mean in that. So in the 4 corners, there will be slightly difference will be there. It depends upon if suppose in the one corner, there is a wall, a glass, it directly exposed to the west side. And that time, the temperature there, it will be slightly 23.5. And you measure this side, this will be 23. And if you go to other corner, it will maybe 22.5. Another one, it is 22.8. And central will be 22. So you have to measure all the things you have to mean. This is what the ASHRAE standard says in that. So similarly, flow rate when you are using the anemometer for measuring and all the things. So these are some of the assumptions when we going for that. So as I told you, air ducting, air distribution depending upon our duct network. Ducting network comes with ducting is maybe ducting as well as supply air terminals, return air terminals, whatever return air system. So the entire family of duct network consists of various parts in that. So generally, all this treated air or even exhaust air or even fresh air. So how we are going to supply it? There was 2 types of system. One is called constant air volume system, which was very old system. Majority of the time we used earlier days, maybe 25 years, 30 years ago. A simple system. We calculate this much dehumidify air, and then based on that we design the velocity. There will be a common duct, common plenum. We have a branch ducts, and we know the load calculation. On that basis, we every wire based on the load, how much CFM is required. We take the grill velocity, and then branch ducts we take. Then we put the dropouts or collar, what we call with that. This is called as a constant volume system at a variable temperature. Similarly, we have a variable. That's what the variable air volume system, because everything has got own advantage and disadvantages. It is when, as I told you, whenever we do this system design, we always system design for the peak condition, a peak load, and then we select the equipment. So hardly that condition occurs very few days in a year or few hours in a year. So your constant volume system, the same amount, even whether the space is occupied by the user or by this one, unnecessarily the energy wastage will be there. But at the same time, there are some application, the occupancy load or whoever it is, their operation is very fixed. They will work this time, immediately the people will come, 100 people, they will stay there for 8 hours, and then the load is completely almost more or less fixed. And then on that basis, we have to go. So partial load applications definitely will give more advantages when it is coming to the variable air volume system in that. So that is what we are going to talk about in that. So these constant air volume systems are very suited for the applications where the ventilation load is constant for a large period of time. It's the same thing I was telling in that. Like, for example, manufacturing facilities that operates almost 24/5 every time people are there. These are the good examples. So the number of occupants and ventilation requirements, almost no variation. It's all fixed in that auditorium and wherever particular period of time when you operate the ACs in that. And okay, always operates at rated airflow, but only when the facility is being used. Same, this is how the constant air volume system, olden days, we design, we use, still we use it also in that. And in that again, we have a single duct system. Because I want to go to the variable air volume system, I want to make you to understand what is VAV box and what is VAV terminals. So for that purpose, I am trying to explain about the existing constant volume system. There will be a single duct system, dual duct system. Sometimes even with the single duct system, there could be a heaters at the maybe in the air handling unit or maybe at the terminal also, depending upon the what type of design you are going to make it in there. So if it's a dual duct means you have to use hot air separately, cool air separately, and some places you may have to mix it as a mixing chamber, and all this have to be connected through the control, isn't it? So similarly, mixed air system is what I'm telling. Whatever the specific type, all the constant air volume system suffer from the same limitation that airflow volume is fixed. Whatever I fix 100 CFM or 200 CFM or 300 CFM, it is fixed. And there is no way to reduce it when the full design airflow is not required. So the only viable control method is to operate fans intermittently with on-off switch. But this is not energy efficient and causes uncomfortable temperature variations. In addition, CAV system in general have a poor humidity control because entire thing will be depending on the dehumidification coil in that. So that is how the research people thought that, okay, why can't I go for another type of system? Why can't we think? So that is how the answer is the variable air volume system in that. So the variable air volume, basically it regulates the volume of the air from the name itself to the zone by opening or closing the damper. And if you see the constant air volume system, whatever during the commissioning time, they set the set point of the damper. Even if you want to adjust the damper, it will be a mechanical linkages will be there, nothing automatic in that. Many times, the air testing time, air balancing time, they put a mark, and they also put don't change the settings. If you see the old places, they must have put a sticker. And because sometimes maintenance people, they will come, this VCD, variable control dampers will be there. So they may, if they adjust it, what happened, the entire air balancing, which they have done during the testing and commissioning time, then they may collapse. Then again, to make this balancing and testing will be definitely a difficult task. And majority of the time, the maintenance people, they create, and some people will have more cooling, some people will have a starvation in that. So that is how in the VAV system has an added advantage in that. So each has a thermostat, and that controls the VAV. VAV itself is another subsystem from the air handling unit. That means at the terminal level. So it will tell in the VAV system itself, we have a thermostat and the controls. And that controls can be also connected to the automation, building automation. So that senses and the building automation sense, and it regulates. It's a partial load, full load. Depending upon that, the control sends the signals, it opens the damper. So that advantage of VAV system or constant volume system include more precise temperature control, reduced compressor wear, and because when you adjust it, the partial load condition, when it happens, your return air water, chilled water temperature also, the delta T also changes. So accordingly, your chilled water, your compressors, you may have a, if you have a circuits of 6 compressors in a chilled water sink, there will be 3 in circuit A, 3 will be in a circuit B. So there should be a logic. In the chiller, there should be a building logic. Because that's what I'm telling you. If operation of chiller is also another important thing. And moreover, here the design of the chiller is you are only selecting. You are not designing a chiller. You give the parameters. On that basis, you are selecting the chiller, chilling machine, water chilling machine that is installed. But that chiller may be a different circuit. There are 2 circuits, or maybe some of the things will be a single circuit. So in the single circuit, there will be multi-compressors, or it will be a single compressor. If you see in olden days, there will be only loaders, like bypass loaders. Cylinders will be, if it is a reciprocating compressor, there will be a 4-cylinder, 6-cylinder engine, just like our car IC engines. So how depending upon the chilled water temperature, this loading, unloading of the cylinders will be taken depending upon your symbol. Old days I'm talking. Nowadays, that all has gone. And that has got many disadvantages in that. That is why these sophisticated controls, all this type of compressors have started, even centrifugal compressors, bigger size in that. So this will definitely allow us to save the energy in that. So this is how you must have seen this VAV terminals, the duct nerve, see that how in the ceiling diffusers we put the VAV box. So that one which I am showing in the figure in that. So it's definitely VAV system has to offer a superior performance. Most of the commercial spaces nowadays we use VAV system. It also have, in addition to the energy efficiency, there are various research because VAV system definitely saves almost 10 to 20% of energy in a typical. Various research have been done on that. And but again, what the VAV system? It depends upon major 2 elements. One is the VAV boxes, which I told you, VAV terminals, and then in the VAV boxes we have fan controls. We could, depending upon the VFDs, variable frequency drives. Normally for the fan motors above 1 horsepower. Basically for higher we always use for the VFDs. But if you have a terminal level also, there will be a small fans will be there. So for that we always call as electronically communicated motors, ECM. This is also same way without that principle only, but mostly if you have any issues are coming, these are taken care by the electrical department, electrical thing in that, electrical control, all this control, as I told you, any air conditioning tender, any specification, any design, 30% of the controls, 30% of the cabling, 30% of the cost, 25 to 30% is electrical engineer. I hope, I don't know how you people are, you give the schematic system, But again, for air conditioning specification, air conditioning bill of quantities, for electrical, for the electrical part, probably you may be interacting with your electrical team or your electrical section in that, they may give in that. So that's what in that type of what type of motor, what type of controls, they may be the better people. Yes. So that all will be there in that. So similarly, these boxes are the zone with the highest airflow requirement is fully open to avoid the wasting energy as per the laws across. This is all your programming. You can do that. And some of the other boxes which is very far away, it can be partially open where the load is required as per depending upon the zone which is a served. And fan speed is also again controlled by the variable speed controls in that. So this type of VAV system offer definitely, this is what I'm telling, almost 30% of energy saving compared to the VAV system, particularly the buildings where the load is highly variable in that. If the fixed load is there, I will always talk about, like, for example, compressor. When you are telling, if you, for example, if you are designing a refrigeration machine or water chilling machine, for the milk chilling machine. So we know all the time the flow is fixed. So probably in that type of application, we recommend certain type of compressor. And but if the refrigeration load is going to vary, we will select a different kind of compressors in that. So that comes under the refrigeration circuit. In the same way, depending upon in air conditioning side, if you have variable load, your ventilation requirement, and definitely we should go for a VAV system, and that helps you to save almost 30% of the energy in that compared to the constant volume system. And 30 years ago, everybody was using a constant volume system, but later stage the technology advances, and then we started using the VAV system in that. So it helps also multiple zone, and the life cycle also cost me very less. You have a lot of low diversity, and these are some of the advantages of the VAV system. This is how it looks like, the VAV box. We'll see more on. This is what I have taken in that. It consists of a terminal box. Generally, this type of VAV boxes are located at the space above the ceiling, above the false ceiling in that. And it will have a blower motor. Even sometimes you may have filtration also. Even have a damper, and then you have now the sensors are also there. But operating time, I have seen with my difficulties, my personal, many time, all these sensors are very sensitive. After the installation, maybe another 3 years, 4 years, this always will have a operating difficulties. And then we need to have a control technician. But majority of the time, when we use for maintenance, we use refrigeration or air conditioning technician. She may be good on the refrigeration side. But here, you are going to use a lot of controls. So we need to have a technician who diagnose it properly, because the sensors are very sensitive. Logic here is to understand when this type of VAV systems are connected to your building automation system, BMS system also, that time he has to also understand this should be also compatible to the software which the building automation system also going to be included in your specification in that. That is very important in that. So this is what we have Train has got a 2-1 that is called as VariTrack and VariTrain. These are the product which I have taken from their catalog. So VariTrack is generally used for the smaller unitary type of air conditioners, and we call VariTrain is for the multiple bigger type of air conditioning system in that. So just this is what we call, the name we call as changeover for VariTrack, and True for the VariTrain in that. But the commercial name is that one in that. So this is all cost effective. So this is generally we use for the packaged rooftop equipment and flexibility on that. Just the layout I'm showing in that, how it works in the package unit in that. So these are all small rooms, offices where we have a small package unit, ductable units, where we can use a church, school, or manufacturing, where we can use this type of VariTrack system, VAV system in that. Mostly we will be using in that. Commercial split, even if you have a ductable split system also, we can use this VariTrack. This all I have taken from your Train manuals only in that. And Train definitely has a very added advantage in this VAV system in that. So much products are there. And all this, even a terminal, probably you may have to use some heaters with the reheating arrangement. So even it's a terminal, you can provide the reheat arrangement in that. So this is that figure actually what I want to say in that. So these all commercially available in the catalogs. You may be having these catalogs also, and what type of available, the details are available. It's only depending upon your design, you have to select it in that. Now come to the very trade actually. So this is basically used for mainly for the bigger central air conditioning system. You have a it can be air handling unit or even bigger capacity, 30 ton, 40 ton package units in that. You have a complicated, complex supply network, and then which is also connected to your BMS. So this type of the location actually, how it should be like this. So this is same how it will be slightly complicated on that. So these are the figures. You can see that one. So these are some of the single duct only. We have also dual duct. As I told you, we may have many applications with the single duct. Some places AHUs may have application with the dual duct application because you may have to control both heat as well as cool also in that. So with that also, if you have a dual stream, it's the dual duct also, but again you have multiple zone also. With the dual stream, we have multiple zone. For example, now you have like this one duct is going hot duct, another is now cold duct in that. So you have blower. So it is a dual duct with a single multiple zone also. It can be so everywhere how this controls, how the supply, how the return is coming. So that is shown in this figure in that. Similarly, some places we may have to put the terminal reheat. That is nothing but your how much QS is a simple formula. You know that sensible heat formula only. So in that case, if you want to put the terminal heat in the cool air, and then you have to put the terminal heater at the end. This is what I'm telling. The cool air supply, it is coming to space. Then you also put the reheat coil, or you put the heating coil, or it can be through the hot water coil, or it can be depending upon what type of system you are going to select. And generally, if I do a heater, if you are providing heater, normally we put single bang or two bang or three bang. I still prefer to go to more banks because you will have more options. Because all the time you don't need all the. If I need say 25 kilowatt of heating load, so I prefer to have 8 kilowatt of three numbers. So I don't need all the time this say 25 kilowatt. So I need sometimes 8 kilowatt reheating. Sometimes I heat automatically, it will switch on. So the banking of the heating system is also another one important fact when you are putting this reheat coil in that. So similarly, this is for the that one what I have shown for the constant volume. Now this I'm doing for the variable, how it is going to work in that. Variable volume, multiple zone, how it is going to have difference, basic VAV terminals, because earlier figures what I have shown was basically for the constant volume in that. So this is for the VAV, basic VAV terminals for the cooled air, how the dampers will be there, because you have a VAV terminals at the terminal point where the supply is there, thermostat is located here. If you see the earlier one, the thermostat is located at the return air side near the AHU. Here it is located at the terminal itself in that. So you have a more flexibility, more control on that. So this is all this VAV system control on that. So just for comparison purpose, if you have a single duct multiple zone with VAV and single duct constant volume multiple zone, just to see the difference actually. What are the facilities here? If you have a VAV single duct multiple zone, you have various zones are there, and VAV system have advantages. At the terminal, you can have more control on that. Depending upon the load, the terminal will control the flow of the air, flow of the temperature on that. Whereas we have a limitations on that. But when the load is fixed actually here, so here we use this type of constant volume system with the multiple zone also. So even where we have to understand whether it is I should go for a constant air volume or constant VAV system. Even for VAV system, when we design what type of control and what type of you have already selected minimum ventilation requirement and how the building is going to be used. These all points you have to consider various data collection itself, like what type of fan, how you are going to the distribution of system in that. Various points I have given where we should understand whether the reheat is required or not required, and Most of the time we should not depend on the digital control side also. So it all depends upon your creative this thing in that. So general, this is again from, I have taken some of the key recommendations from the research paper, which probably, which may be useful to you. As I've been telling, I've been always telling, insisting that we should always go for an integrated design. Everybody, architect, structural engineer, and we have to also coordinate with all the staff for the air path. Many places I have seen the shaft what they have given may not be sufficient. Even the gap between the ceiling height and the false ceiling height is very less. We may not have even the place to locate our VAV boxes. And then same way you have to also understand there are many services running above the false ceiling. There will be a firefighting, there will be a fire sprinkler system, and then light fittings. Light fittings also nowadays have become so advanced level, sleek and everything. So on that way, architect always try to reduce because they don't want to create the ceiling height more also. If you see that in the earlier days, normally we have even some buildings, we may have a height from finished floor level to the ceiling height, we may have even 2.9 or 3 meters also. But nowadays you don't get even below the false ceiling, you don't get even sometimes 2.6 or 2.7 also they don't give. And because the height, because they don't want to have the cost reduction. And maybe the height limitation is also there. Architect will, if it is a multi-story building, he always have a height restriction in that. So this probably you may tell, sir, we have advanced software and all the things, but depending upon your foundation, depending upon many factors are involved in that. So this comes by only experience. So generally, you should always use a powerful modeling simulation tools, which I've been telling every time. And then you also have the matrices, risk analysis, man. When I take this one, how I have to interact with my fellow service, other electrical engineer and architect, structural engineers. As much as possible, you keep the air shaft very close to air handling unit so that you can avoid the pressure drops of taking the duct routing, and use the planum actually, because if you use the planum, definitely it will help us to reduce the energy cost. But maybe because of space constraint, you may not be able to use that one. But that will also have an effect on your performance of our system, your air handling units. So similarly, you have to also understand system to handle the auxiliary loads that operate during the off hours in that. So these are some of the how to zone in that. This is also another art rather than a science. That's what in the first class also I told you. You have to make a free ducting routing diagram and the zoning diagram, and then you have to sit with everybody and you have to finalize it. Don't combine the zones with a different kind of requirement. As much as possible with different temperatures, with different requirement. You don't combine the zone for corridor with the lobby. Lobby or maybe some other area. So this all becomes the standards also clearly staying in that. But you all more than standard, what you need is your experience and the end user. You have to sit with him. Similarly, in many times you also use this type of indoor as a part of indoor air quality. We use sensors, various type of sensors to understand the air pollution level, actually, particularly carbon monoxide, carbon dioxide. There are some places when we keep oxygen sensors also in that, depending upon what type of design you are making in that. So the VAV box selection also depending upon whether we should go for what type of box, what type of control we should apply, because whatever the control you are taking decision, that has to be informed to your BMS vendor also. He has to also write his soft programming according to that one. So this is basically some of the design points probably you should keep in mind when you are designing for the VAV system in that. And then, as I told you, duct is a part of always. Duct design is always a very interesting one and very complicated one. Yesterday also we were discussing what type of material we use the clean room. We have to use specifically only aluminum or stainless steel, preferably stainless steel. And then the question came, why can't we use a GI? Yes, definitely for clean room it is not required. Some places we use the PVC duct. Some people we use even concrete duct we have used, many applications in that. Where that might be industrial applications in that. PVC duct, we use a lot of chemicals related to the chemical factories and all the things, depending on that. But general rule for comfort application, which does not need much controls, cleanliness, more than 100,000 class level, we always go for the GA duct. Because when I go for a stainless steel, it is definitely expensive. So cost is a consideration. That is the main thing in that. Otherwise, even if I have a lot of money, I will go for my stainless steel ducting. We don't have any issue. Definitely, we can go for that. And I have also shown some of the design parameters earlier, the ducting, how we have to take the elbows and joints in the drawing. But more than, because when you do many things during the design, you don't anticipate the site consideration. So whatever you do, even the working drawings also, after that, working drawings are coming to you and you approve it. But later stage, when during the execution time, the project engineers or the resident engineer, the air conditioning resident engineer, when this type of going to be installed, there will be thousands of problems. And as per the site condition, they have to do some changes. But many times they don't inform. And then later stage, it has become a serious problem during the testing time and commissioning time. I think I must have told you one of my case study. I was designing one factory somewhere in central part of India, but I was doing design sitting at Delhi those days, the drawing board. And the chilled water pipe length, which I estimated, it goes approximately more than 3 kilometers. Because the plant room is somewhere else, we have to take all these pipe to various air handling units in various places. And I always, as a design, I don't normally I take factor of safety when I calculating these frictional losses. So I have selected a pump based on the static pressure, whatever it is. And then on that basis, I have put my bill of quantities specification I have written for the primary pumps as well as secondary pump, whatever those days. It's a constant volume system actually. It is not like VAV. I'm talking those earlier days. And then as a design engineer, I have given the procurement department, where the contract is awarded, a major civil contractor. There are some site engineers, and they executed. The project went almost 2 years or 3 years because it is a very massive project. And so during the project execution, generally as a part in the site consideration, there will be a measurement, piping measurement, measurement book will be maintained. Every pressure, because most of the chilled water pipe is insulated and it is taken through the underground buried pipe. There is a specification. ASHRAE also very clearly says that from the finished floor level, it should be buried about 1.2 meter or 1.3 meter. And then pipe, depending upon the diameter, there should be a plumber block, and then sand should be filled, and how much that should be the trench width and everything. So all these things, and then section wise, it is all majority of chilled water pipes are MS pipes. Nowadays, MS pipe is also replaced by all these high density HDPE pipes also for the chilled water line. That's one advancement actually. So when this type of MS pipes are welded, and they normally section wise, they do the pressure test. So if your system pressure is approximately say 2 bar or 3 bar, we always say that this should be pressurized. Hydraulic pressure test, we do it in that. We put the hydraulics in water, we pressurize that whole system. Both end, we close it with the dummy plate, and we pressurized, we keep it 1.5 times. Ideally, we should be two times the design pressure. If the design pressure is 3 bar, we keep it for 6 bar. The pressure we keep it, and we allow that system to keep it for 24 hours. So after the 24 hours, we see the pressure gauge. If there's no pressure drop in that, that means that there is no leak in the piping system. This is what normally we do those days. And so there is a record for that pressure testing, because segment wise they do. And that time they also measure it, because the bill of quantities, we pay the piping based on the total length actually in that. This much diameter, this much length. Then after the actual erected quantities only, we pay for that. So when this project, what happened, this changed the pipe routing in many places depending upon the site condition. And the last air handling unit, the final one, which was very far away from the plant room, we had some issues. The chill water flow was not maintained through the coil, so we could not do commissioning in that. Then later stage, we found out what really happened was the flow rate, the GPM, the gallons per minute, which has to flow, that what is not reaching there. So this is because of the change in route. So this is what I'm telling. Same thing happened in the ducting also. In the duct, basically air is used. In the chilled water pipe, the water is used. That is a different in that. So all this type of duct design, when you are doing it, as much as possible, your branch ducts, elbows, everything you should consider on that. And similarly, you should also understand the duct liner. And I don't know how many people must be doing this acoustic treatment of ducting. Maybe depending upon you may be also doing your specification, that is to reduce the noise level, especially when you design your duct velocity, supply duct velocity, higher velocity, and if your air handling unit is very near to the very office area or something in that. So in order to that, we normally do the acoustic treatment of ducting also. Even sometimes if you need, we do the acoustic treatment of plant room also in that. So the supply temperature approximately we know that, and the demand fast static pressure fan only we normally select it actually. Where fans and blowers are basically another important topic which I told you. You have different kinds of fan. Centrifugal fans are generally we use blower. We don't call fans, we call axial fans. Axial fans also van axial, tube axial, and most of these axial fans are used for the exhaust because it has got its own characteristics. But when it comes to air handling units, we use a blower. It can be a backward curved or forward curved or normal curved. Everything has got its own plus and minus, and the standard specifies also in that. Similarly, we have a coil that we have discussed many times. Similarly, when you come to the coil, then filters, we have done a lot of study yesterday. So what should be the phase velocity, coil phase velocity, and also you should ensure that this water eliminators should be very clear above before the depending upon the application. Then similarly, we have go for the outside or air return air exhaust control. For outdoor air control is a dedicated minimum ventilation damper with the pressure control. Everything should be interlocked with the BMS system. So you also have a manometer, digital barometers. You use it for measuring this type of pressure differences, and then accordingly the control should be also used in that. And when we are talking about fan type or fan size, depending upon sometimes like places like operation theaters, we may go for duty, we may go for even standby, because operation theaters cannot be stopped even 1 minute or 1 second. So we machines will definitely, and moreover, we need this type of 24 hours, this type of units are running. So they also need their regular plant preventive maintenance. So that time you have to shut down. So it all depending upon how much type of redundancy you are planning. So this is all the initial planning stage you have to understand. So that is what again I am insisting, your interaction with the end user, understanding of the use, and then the architect also should understand properly the coordination between you and electrical engineer and other end user, and that is part of the integral design in that. And some people will always think why I should go for initial capital costs, though it is a redundant application, and all the time it will not go. So this all has to have a risk analysis study in the design. And again, depending upon the fan efficiency, the fan efficiency curves are available. And then definitely when you go for any centrifugal machine, there is a surge available. You know, in the surging in the centrifugal, whether it is a pump or it is a blower, surging is another important issue in that, and the part load condition. So that is also to be addressed during your design stage in that. Just talking about mostly in the air handling units, you have a centrifugal type because it can be a backward or it can be straight or normal blade actually. And then which applications we are using in that housing type, it will be a scroll type, just like we see centrifugal. As I told you, there is no much difference between a centrifugal blower and pump. And in the pump, probably you have a casing, then you have a volute. That's what the difference. The terms will be different. Here we call that is a mechanic. There it is handling. It may be a water, it may be liquid, or it can be a chemical, it can be a slurry. If it is a pump, centrifugal pumps. But in this case, we are basically talking about the air. It is dealing with the air in that. So what type of housing type? So this is what you normally can improve in your design stage and in the air handling design. But the limitation here, you normally don't do all this type of thing because you are only selecting this type of AHUs. But you can always write your specifications very clearly. So you have the option now to design when you go for the design evaluation when the tender bids are opened in that. And then you always select, and you can always advise the people in that to the end user. the owner of the building, the owner of the or architect, whoever it is, who is appointing you. You can give the clear professional guidance to him. So all pros and cons you can explain to him. Then we will leave to them in that, in a proper format. The proper matrix has to be developed and it has to be given to that. Now, similarly, some of the applications, like if you have a forward code, this also I compiled it from some standard only. Similarly, backward code, what type of application, how much CFM it will handle, what type of static pressure, then what will the cost, forward code will be lowest, manufacturing cost. I don't know how many of people have visited the manufacturing factories where they are manufacturing this type of blowers and AHUs. It's all basically sheet metal work. I have visited even some plants in Ahmedabad, actually, long back in '83. I stayed there for about 1 month and I took implant training and how these people are fabricating this type of, and then also how they are doing the balancing, dynamic balancing once the sprawl is completed and when they put all these things in there. So this all is a very interesting topic, a very interesting one. So general idea, this may be useful to you in that. Now this all again performance curves. This performance curves also it goes as the age goes actually. Many times air handling units, I have seen some of the, when I go for a refurbishment project, some of the air handling units are running 24 hours continuously for even 30 years, 40 years. And there is another association called as Air Moving Association from America, the company's association, Air Moving Company of America. They are doing a very professional this thing. Even I will send the link to you. I am also in one of the member in that. Regularly, they conduct online meeting and they understand every part of air handling units, blowers, duct design, simple part also, even fixtures, they will go very detailed into that. Some of the meetings I missed it, but some of the meeting when I attended online, throughout the world, throughout the globe, people are there in the member actually. This AMCA website, there is Air Moving Company of America. They are doing a very professional approach. And then they also nowadays, they are started introducing the fan energy index, another new terminology called as FEI, fan energy index in that. So this fan energy index is also slightly different from that. Normally we talk about the ducted and ducted versions on that. During the testing time, we do that one. No, this fan energy index is slightly different than that one. So this is in developed in US, and then these regulations are still they are to be completed on that. But I can send this link for this AMCA link. It is a very professional body, and they are doing a lot of work on that. Okay. Now here I want to talk about in the fan power, because when I want to talk about various other things, majority thing I have already covered actually. So this is one area probably I have not given to you in previous classes. That's what I have taken in that. So if you talk about in a fan power, you have electrical power. In that, how much loss, motor loss, drive loss, how much will be the bearing loss, and how much is the aerodynamic loss, and then finally how much is the fan power output. So this will be available when you go any fan manufacturers, the catalogs in that, and how much will the fair shaft fan power we are getting, and similarly with overall fan power, how much we are getting in that. So this will be definitely you may be using a lot of fan catalogs with you, manufacturers catalogs. There was called as Air Conditioning Corporation of America. There was a company earlier, and similarly Flacket India. Flacket is originally US company, but they also are having big manufacturing plant, I think somewhere in Calcutta, I think. This type of thing, they have so much handbook, so much data are available with them. Earlier days. Nowadays, I don't know, you may be having more updated manufacturers on that. So that's what you have to go for the fan efficiency grade as depending upon that one based on that. So actually also now talking about all this idea, what is a bare shaft fan only on the peak fan efficiency, because when you are selecting this fan for the whether it is a blower, when you are taking, instead of I should use blower actually, because most of the time we get confused, but fan is a general term in that. Everywhere they are using like that only. The fan efficiency grade depend upon this one. We have also fan motor efficiency grade, FMEG. So it all depends upon because you have electrical motor, and you know that energy can be neither converted nor destroyed, but it can be converted from one form to other form. There will be always the losses will be there. So depending upon that, they have different rates and performance curves are there. On that basis, your then again the drive system also. What type of drive system, what type of loss, and all that. These are the matrices atoms. So these are some of the regulatory challenges. Like as a generally, we always go for a smaller diameter fan for the lowest first because we want to have the lowest first cut. But actually, always provision for selecting fans within 15 percentage points of peak load total efficiency. Ashley has very clearly regularized. The sizing and selection window generally complicates application and enforcement. And as I told you, majority of the time, we always go for over design. So Ashley has given a very clear guidelines on that. So these type of things, efficiency varies with the size for the duty point. Because
May
fans.
I ask something, sir?
Yeah, please.
In the last slide, when you are saying the 90.1,
Yes.
that allows to be approximately, in 15% of uh, peak load, where you can run your of your peak
Yeah.
demand, you can select your system, you select your fan in
Yes.
15% of range.
Yes.
Yeah, within 15% percentage points of peak. So if I
No, no,
select it,
15%
suppose,
you can, no, 15% you have a margin, extra margin in that
okay,
for
that's
selecting a
I
fan.
can go
Yes.
like above than
Yes,
100%,
that's right.
not below,
Yeah, correct.
right?
Yes,
Yeah, that's
yes,
what I
that's right.
wanted to confirm.
Yeah, that's right. Yeah, that is the meaning. Yes, maybe.
Sure, sir.
Maybe I have typed slightly wrongly in that. Similarly, the fan efficiency varies the size for a duty point, various diameters of the fan. I wish, I think you people should also, this is what I have been insisting, every time you should always go for a factory inspection. This type of fans before it is dispatched to the site or before it is used for the assembling of air handling unit, you should go and do the performance test at the factory itself. That will definitely give you an idea in that. So, so this is what the factors which I want to say, that how much you see that, and when we see the difference actually when the fan size goes with this efficiency, how much it is coming in that. So that is idea in that anyhow. So now why we want to introduce this FEI. This is another concept, fan energy index in that. So that probably we will just go. We'll have a 5 minutes break now.
Sure, sir.
Okay, thank you.
Hello, sir.
Sure. Can we start?
Yes, sir. We're good to start.
Okay, please. Okay, thank you. So I will quickly recapitulate whatever the things we have done in the today's thing. We have understood what we need to have a VAV system. It's a latest technology in maybe for about 30 years old or 25 to 30 years old, and how best it is different than the constant air volume system, which has been used earlier days. But both the system has got its own advantage and disadvantages. So we have also compared it whether it is single zone or multi-zone or single duct or dual duct. And then we also generally we talked about, particularly I'm focusing today more on the particularly VAV system. We need to have a VAV boxes, the terminal boxes where it is mounted. And I told the train brand name I have also shown. So then we were focusing mostly on the fans and blowers, because this is very important part of the air handling units, as well as even if you are going to have a in the VAV boxes terminals also you are going to have a small blowers. So that all depends upon your fan efficiency and fan performance. So performance curves, that what we are discussing so far in that, and some of the standards also we have cross-referenced. As I told you, this Air Moving Corporation of America is another professional body. You can always visit there. They are developing this fan energy index now. It's a manual also. I will show it to you in that. So they want to introduce this concept to improve the right size of the fans. So that will help you to have a gain for the energy savings. Maybe later stage, this may also, they may include in the your credit, lead crediting and all that later stage. So this is various discussions are going on that, and it's also I said 91 point, and also it covers some low pressure fans, and then even to cover the integrated motors and drives that are exempt from, some of the motors are exempted from AMC 205. They have also some standards on that. So why we have to do basically to improve the fan selection rather than remove the inefficient fan models. Just we want to improve the selection. You have more opportunities for that. The selection should be more efficient. And then manufacturers of the fans who are manufacturing, they will also their efficiency to improve the higher efficiency operating points. This fan has got different operating points. If you see the fan performance curves, that you all basic mechanical engineers, they know in the pump, whether it's a pump or fan, we have operating parameters, operating points. Various speeds depending upon, that's what we call the performance curves. So, so we also will have learned better design practice and have more flexibility to optimize the fan system for efficiency. And when the fan runs, we have a lot of sound problem. You have acoustic noise level. Noise is also another one area. Probably I have not even addressed the decibels level, what you have to control. Then size and costing in that, but efficiency and acoustic from technical point of view, and cost involves many other factors, because material science, material people, availability of the materials and all the things. So that probably I may not be doing much, but for that we have a different type of cost engineering is there. But whatever we do with the standard, with our experience, as a thumb rule only, we'll take it there. But detailed cost engineering, we have to have some more specialized engineer only who normally design on that. But at least we should have more understanding about the efficiency and acoustic part in that. So that is what, that is the reason they are using. There are some numerical formulas which they are using. Simple, if any efficiency means the ratio of output to the input. So everywhere, the same thing only they are using. Then some formulas also they are using. I have collected from this manual only. So for ducted application, for non-duct applications, they put some coefficient also, the efficiencies on that basis. So these are just for reference. You can take it, and I have also, maybe I will share the link of this AMCA link. You can get more details if you really want to go more deep into the fan selection and fan engineering in that. So, so this is for the selection region bubbles. We may, all the time, any design engineers, we always have a bubble actually in that. So that is the reason that FEI, we call it as fan energy index. So that is the reason they are using this emphasis, and for that purpose only this manual is also. See, this is what the manual I want to show you. AMCA worldwide certified ratings FEI, the energy index. This is, if you go to the website, you will get all these details in that. So even this is now added to the Department of Energy US in the modeling software. So this is what already added in that. Similarly, this is added to the assessment tool, and but certification from the AMCA added, but fans are still not yet certified in that. So these are the status of this fan energy index in that. So that's what I just wanted to know. But if you have interest more on that, you can go to their website of AMCA website. You get more details on that. I also strongly recommend, and this Steve Taylor, he's a website that he has given very interesting guidelines for the sequences of operation. Some of the tips he has given, particularly VAV controls, and when we are using multi-zone and single zone. I really wish that I should have downloaded everything, but I thought I just give the link in that. Probably you can have a further readings. You can go that. That's what that I would, how we have to set the VA boxes minimum airflow to minimum ventilation rate, and why. What are the reasons? And very beautiful graphics also he has in that. He explained that. If you have time, you can go through that one. So this is some of the tips he has given when we want to design for the VAV system design in that. It is not, but most of the things I have also covered. The extract I have covered, but if you want more detail on that. Now next is basically come to the fan. When you come to the construction of the filters, that we have done so much research, so much done. Yesterday also we have done. We know about what is MERV rating and how the construction of the filters. Yesterday we have seen what type of frame, what type of filter media, and even how when the air passes through that, how it is getting filtered, and various kinds of dilution. This is all we have seen yesterday in that. So all this spot efficiency, actually also we have selected different kind of ratings also. So this type of filters, the HU, similarly coil selection also. Yesterday we discussed what should be the velocity. As the standard also recommends selecting of coils for under this much water pressure drop. So we should not have a coil more than pressure drop. Then I also talked about, we should also talk about the micro channel heat exchangers. So where we in the coil selection also, so much advancement has come now in that. That maybe also you can use it for that, for a micro channel heat exchangers in that. Definitely, we know that VAV system is an energy saving technology, and in the design and controls and VAV boxes to be suitably selected. In the basically, when we want to design a VAV system duct design optimum, is you have to mainly focus on the duct design, routing, zoning, and the location of VAV boxes and its controls, and then it is integration with the PMS. So we need to have a proper guidance for the maintenance of the VAV system. Also should be included in your document, because that is how they are going to put in our O&M manuals. Whatever you do, whatever you design, after you install it, if the VAV systems are not properly maintained, it is going to have a hell of a problem. Instead of energy saving, it is going to have a energy intensive. It becomes in that. So that is what. But I am sure we have so much advanced design tools, and VAV system design definitely will become more easier in that. So that is what I can say in that. And thank you very much. If you have any question, please ask me in that. Yes.
Yes, sir, I have one doubt.
Yes, please.
This for VAV system, it is normally seen that backward curve fan with high static only are preferred. So is there any reason for that?
I have given that the comparative statement. You see that the fan for backward curved comparative statement. When majority of the thing we go for the, you see that this is the one backward inclined centrifugal. This one backward curved actually, backward inclined actually. So what are the typical application when you have the CFM ranges from 25,000 to 70,000, and the first cost is it comes within the medium and low. What are the space constraints? It requires more space than the planum fans for smooth discharge. And what are the efficiency than the housed airfoil design also. So this I have compiled it also. This will be useful. But as I told you, it all depends upon the air handling unit manufacturers. What type of air handling unit you are going to select it. Most of, if you see this Italy, this Euroclima, this is also from Europe they are manufacturing, and maybe even train they have different. They have different brand names. Xavier from Italy, they also have that this brand name in that. So every choice, but advantage is mainly we use most of our air conditioning applications. We use this type of backward inclined line. So advantage is because of its performance in that. Yes, and application to application. It all necessary. It is not necessary we have to go for all the time with this one. It all depends upon your design and your selection. Though the gate says in that, but you can always, if you feel that the planum airfoil centrifugal is more advantage application, then we can go for that planum type also in that, which is very higher capacity you want to design. You want to have a bigger, but in that case you have to also compromise for the noise level, acoustic treatment. It depends upon the industrial applications in that. But if you are now designing for a hospital air conditioning, where you have the air handling unit rooms are kept very near to the service building services that are within the hospital premises. So you have to also consider many other factors in that. So if there is no question, I will just recapitulate whatever the things we have done, because this will definitely will complete the air side actually, because tomorrow's class we will be talking about the certification of the lead, BREEAM, and well feed and globe, green globe. So in that we will definitely give the cross reference of all these points. And then another class, Friday's class, I will be concentrating mostly on the your stairwell pressurization system, ventilation in the more on the ventilation side on the multi-story stairwell ventilation, car parking. So that will be that probably you don't have much on refrigeration application on that. So that is the reason this all these subjects we combine, starting with the sustainable air conditioning system design. Then we moved into the hospital, very specialized design. We have also talked about various standards. And then we also talked about the indoor air quality, another important area. We have various strategies, how we can eliminate it. And then we also talked about the energy efficiency of all the, whether it is a chill water system, even how we can do in the air side also, air handling unit and air distribution, duct design, and then clean room, various kinds of clean room we have seen, because this is all interrelated. All are one complemented to each other in that. And then particularly finally in the VAV system today. And I have also time to time I have sent some of the study materials, some notes also. Even I have shared today a handbook, probably about 166 pages, and that maybe definitely will be useful to you. Because every time, as I told you, if you want to refer the Ashley fundamental handbooks, these all, first of all the volumes, though they are updating every 4 years, once in every 4 years, but referring that particular section, it takes a lot of time. But this is very, very abstract, very precise, and all the sections are very beautifully covered for the air conditioning system design in that. And I'm sure many of you must have a lead certification. Probably you are, or you must be on the way to get the professional certification for the lead exams also. And but the course, probably what I am going to talk about is the tomorrow's lead is related with the certification process, the credit points, and how we are going to design our air conditioning system design and ventilation system. Though I will cover a little bit about the other services, but because every service has got different points in that. So that is what we are going to do it tomorrow in that. So if you don't have much question, probably I have to also slightly leave today early. Can if you have any question, please ask me. Otherwise, probably I can say thank you very much in that. Mr. Neeraj?
Yes, sir. Yes, you have covered all the points regarding VAV today. You have including the selection of the VAV also. You have classification of VAV. You have covered. You have given this specification of the VAV and this chart, which we can see that is also very, very important. Apart from that, any doubt is there, the Pinnacle team will definitely.
Yeah, even they can ask also. They can send the mails later stage also.
And
we are
you have given me today the handbook, and
Yes.
which I will be uploading by today evening so that they can access it by tomorrow morning.
Yes, in that, yes. They
And
can,
tomorrow's
but
topic.
PM,
Yeah.
BMS, have you uploaded that one? BMS specification?
BMS and today's I will upload it both today by today evening.
Yes, and still some more notes I will be sending for the BAB also. In that, it is there. I could not send it. I will send it actually.
Okay, that also I will upload it. I will wait till today evening so that I can make a zip file and I can upload it in one go.
Okay.
And tomorrow's topic is very interesting because it's mostly a theoretical topic and very important because it's a contemporary to the current industry. Yes. And there are many misunderstanding about that topic, so that will be great fish for us to understand in details what the green building means and what the really important, why it is really important, and which things are really not necessary or necessary. That will be a very interesting topic.
Thank you very much, Mr. Neeraj. Thank you very much to all my engineers, and thank you very much all. Thank you.
Thank you, sir.
Thank you.